and the fuel valve to be closed. Between fuel off and idle is an intermediate fuel on position, which is used during a FADEC off start. The thrust lever is mechanically linked by cables to the HMU. Numbers 1 and 4 thrust levers have an auto throttle disconnect button on each outer side. Numbers 2 and 3 thrust levers have a toga button on their front face. This button signals the flight guidance system to engage the takeoff or go-around modes. A fire warning light is fitted in each thrust lever. FADEC. The FADEC system consists of a hydro-mechanical unit and electrical control unit on each engine and provides the functions listed here. During FADEC manual reversion, the fuel metering valve within the HMU is mechanically controlled. Under FADEC control, the mechanical link is broken and the thrust lever angle is electrically transmitted to the ECU, which then electrically controls the metering valve within the HMU. FADEC trim control of N1 is between 5% at high thrust settings and 18% at low thrust settings. The FADEC status panel above the PED contains the FADEC trim arrows and the FADEC fault indicators for each engine. The fault annunciator illuminates to indicate a FADEC failure. FADEC will also illuminate on the central warning panel. FADEC is selected off by pressing the fault annunciator. Following a FADEC failure or manual reversion at high thrust levels, the engine thrust is frozen until the lever is retarded to region. Thrust rating panel. The TRP provides an interface between the pilot and the thrust control system. It allows the selection and display of any thrust rating as calculated by the flight guidance system and the setting and display of the EFIS speed reference bugs. In order to extend engine life, a takeoff thrust below maximum rated thrust can be used. This is done by basing the takeoff thrust calculations on an assumed temperature which is higher than ambient, which produces a lower thrust. This is called a flexible thrust technique. When the aircraft is on the ground, the TRP is selected by pressing the toga button. In flight, pressing any of the buttons on the front of the TRP will select it on. Selection of TRP modes provides appropriate M1 targets to FADEC and for display on the flight deck. Click on the TRP thrust mode buttons to view information about each mode. Each thrust rating is continuously calculated for pressure, altitude, temperature, and bleed selection, and is displayed on the PED and in the TRP window when the rotary selector is set to N1. By moving the rotary selector to temp with TOGA max as the selected thrust rating, the sensed outside air temperature is displayed in the window when the rotary control is turned clockwise by one click. A correction to OAT may be made using the rotary control. The flight guidance system uses the lowest of the set and sensed temperature in its calculation of N1 ref. With TOGA reduced selected on the TRP, the temperature displayed will be T reduced, a standard increase over OAT.
Do it, please.
N1 reduced is now displayed on the PED. T reduced may be manually amended to any temperature above OAT to produce T flex and a related N1 flex. Due to manufacturing differences, each engine produces a different thrust for a given N1. To ensure that rated thrust is not exceeded at the maximum indicated N1, an electrical bias is applied to the N1 signal by FADEC to make all four engines appear to be at the same N1 without exceeding maximum rated thrust. When equal thrust is required, compensation is applied to the N1 signals to the primary engine display and the flight guidance system. This occurs when either TOGA or MCT are selected on the TRP. Equal thrust is then achieved by each engine at apparent equal N1s. With climb norm or climb max selected on the TRP, the compensation is removed to synchronize the engine's true N1s and so reduce cabin noise. The TRP rotary selector is also used to enter the bug reference speeds V1, V cross, and V dot on the EFIS speed tape. When V1 is selected on the TRP, a bug is placed against the speed tape and the V1 speed is repeated at the bottom of the speed tape. The V1 speed and bug disappear when the aircraft is in flight. The TRP is selected off by pressing either the auto throttle disconnect buttons on the end of the thrust levers 1 and 4 for longer than 3 seconds. Auto throttle. The link between the flight guidance system and the auto throttle servo motor adjacent to the thrust levers allows full authority thrust control by the flight guidance system. The auto throttle is selected on ARM using the switch on the mode control panel. This can only be done if the TRP is on. Indication of auto throttle engagement is given by the green light adjacent to the switch on the MCP, and AT in white meaning armed, or green meaning active on the PFD. The auto throttle is disengaged by using either of the auto throttle disconnect buttons on the thrust levers 1 and 4, or by deselecting the auto throttle arm switch on the MCP. When the auto throttle is manually disengaged, AT on the flight annunciator illuminates for 4 seconds, and AT on the EFIS flashes for 4 seconds. An automatic auto throttle disengagement is indicated by the same warnings, but they will remain on until canceled by pressing either auto throttle disconnect button on the thrust levers. The thrust control system has the here listed modes of operation. Manual reversion. This is the most basic form of thrust control, which is made by movement of mechanically links to a fuel valve within the HMU of each engine. No engine parameter limitation protection is available apart from fan overspeed protection at 104% N1. N2 ground idle will be between 49 and 75%. In flight, the pilot must ensure that minimum N2 is manually set. Thrust automatics off. The FADEC is selected on. The thrust lever's control of the fuel metering valve in the HMU is disconnected, and the electronic control unit now controls the metering valve electrically. The introduction of FADEC allows greater engine control and performs engine limitation protection and N2 idle control. N1 is limited to 97%. N2 is limited to 98.8%, and EGT is limited to 649 degrees Celsius. Ground idle is controlled to 50% N2, but depending on environmental conditions, it may be